Welcome. In this video, we'll be solving equations using logarithms. Now, in previous videos, I've used log of different bases, but in general, in a lot of cases, people just write log. Logs, when they write log, they mean log of base 10, because in natural counting, we use numbers in base 10. We can also use log of base 10. So if you have a log button on your calculator without a base, that means that the base is 10. So every time you see log, if I had excluded writing this 10 here, if you could presume that I'm using the base 10. So to answer this question, previously we would have said that go ahead and find log of base 3 so that the base and the base of that index will cancel away. But you don't have to do it, because in that case you would have to type a lot of you just have to type two things on your calculator. What you can do to solve these equations is to naturally just use log. You say let's bring the x at the front because x is in the exponent, and then divide both sides by log of 10 base log of base 10 3. You could have written it like so, and you wouldn't have to type 10 on your calculator, because when you press the log button, this will come up. Now, that's the same as also, well, you don't have to write the decimal numbers. The answer is that, and you can type this on your calculator as well. Instead of that log, you could have used ln. ln stands for natural logarithm, and that means log of base e. Now, we said when you change the base formula, it doesn't matter which base you use. In fact, there are infinitely many bases in of logs. It will give you the same. The ratio will be the same. Okay, so let's look at the next example. Here, again, first we are just using abstract mathematics. You don't need to get your calculator out. First, you rearrange the formula. You use logs to bring the powers down, and then you can isolate. You need to isolate x on one side of the equation. That means that you have to expand these brackets and have them like so. When you're expanding brackets, the log will stay there. You have to, I'm afraid you have to write them 4 times. And now this term here has an x, and so does this term here. So to rearrange them, as long as you bring them to one side of the inequality, we subtracted this and we brought it here. And that means that we send this log to the right. So it was a plus here, and we are subtracting it from both sides. So it appears as a minus log 7 on the left, on the right. And now using logarithm rules here, we can say when two logs are we can factorize the x out of both and write it as one log. Log of 7 minus log of 3 is going to be log of 7 over 3. Alright, so factorizing 7 there, and then going to rewrite it. So we'll have this expression here, dividing by that. Well, we didn't rewrite it as one log, okay, that doesn't matter, but you can type this on your calculator. It will be a bit longer to type. You could have simplified this to a log of 2 log of 3, or log of 3 square, 9 over 7 divided by log of 7 over 3. This would have worked just fine as well. You don't forget, now don't simplify this any further. This doesn't simplify anymore. 2 logs divided by each other are 2 logs divided by each other. So to solve these equations, we have to do what? Notice I've kind of given you a clue. Well, let's just ignore that. That's not a good clue at all. So let's say that we want to solve this kind of equation. If you glance back at your book, right in chapter 1 or chapter 2, when we solve quadratic equations, I said you can swap these two around and write this as 5 to the power of x squared. Now, does that give you a clue? Alright, so this is the same 5 raised to the power of x. So we can, if you like to replace it with another letter, you can. You can think of it as z squared minus plus 7z minus 30 equals to 0. Factorize that. So what are the factors of 30 that add up to 7? 6 and 1, 6 and 5 don't work. Uh, 15 and 2 don't work. There must be a factor. Uh, if we think about it, we will get it. So we got 6 and 5. How about 3 and 10? Yes, you can use 3 and 10. So we write z here and we say I need to have a plus 10 and a minus 3 so that the sum is a plus 7. So that means that z equals to 3 or z equals to negative 10. Now, can I have remember z was 5 to the power of x, so can I have 5 raised to the power of x equals to a negative number? This is invalid, that's not possible. But 5 raised to the power of x can be 3. How can we solve that? Alright, that's why the clue is there at the end. So to solve this, we can use logarithms. We can just say log of base 5 equals log of, log of 5, log of 3, and x will come and multiply at the front. So we can say x equals to log of 3 divided by log of 5. And that's the same as having ln of 3 divided by ln of 5. Okay, so now I'm gonna rub off my handwriting and let's look at it. So notice I use the same substitution, z equals 5 raised to the power of x, and I will get the same answer. So I'm using here a different letter, y, rather than z. So in the end we have just the same answer. Why do we ignore this? Because that just doesn't have a solution. Alright, good luck, I'll see you in the next video.